thrilled to welcome you to our session today. We're going to dive deep into the world of system design, starting right from the fundamentals. To understand systems, I want you to imagine you're building a restaurant. It's about so much more than just the food. You have to think about the kitchen layout, the number of waiters, and how you'll handle a massive Friday night rush without everything falling apart. This analogy is perfect because, just like a restaurant, a software system needs careful planning of its internal components to serve its customers effectively. Formally, system design is the process of defining the architecture, modules, and components of a complex software system to meet specific needs. It's the blueprint that ensures everything scales and functions correctly. Throughout this session, we'll use these ideas to explore how modern apps handle millions of users. Let's move on to explore the definition of system design in more detail. Building on what we just touched upon, let's look closer at what we actually mean by system design. It's a term we use a lot, but let's break it down into three core pillars. First, the formal definition. It is the process of defining the modules, interfaces, and data for a system. Think of it like a blueprint for a building. Before you lay a single brick, you need to know where the plumbing and the electrical wires are going to go. Beyond the technicalities, it acts as a critical bridge. On one side, you have a business problem, like needing to process payments securely, and on the other, you have a technical solution. System design is the strategy that translates those business needs into a reality that actually works. Finally, we always keep the end goal in mind. We want to ensure that our systems are efficient and reliable. But just as importantly, they must be easy to maintain and scale as the system grows. We don't want to build something that we can't fix or expand later. To really understand why maintenance and scaling matter, let's look at the digital giants who face these challenges every single second. We're moving from theory into the real world of massive infrastructure. Think about Netflix. They aren't just playing a video file, they're streaming high-definition content to millions of users simultaneously without a hiccup. Or look at Google Search. It indexes the entire web to deliver your results in a fraction of a second. This level of performance is the direct result of intentional system design. Uber is a perfect example of real-time coordination. The system has to match thousands of drivers and riders instantly while calculating traffic, pricing, and optimal routes. It's like managing a global fleet of taxis with a single, highly efficient brain. That analogy of a global network is spot on. Every major app you use is a masterpiece of engineering. Now, before we look at how to build them, let's reflect on the apps we use daily and the complexity hidden behind their simple interfaces.